So let's get it started. I'll just go ahead. All right, so welcome everybody. I'm going to be talking about developing zero knowledge solutions with JavaScript. I'm going to go use interchangeably the term zero knowledge and also client-side encryption, but I'll go and make sure to specify which one is which. I'll just go ahead and start because I don't have that much time, so I'll just try to go ahead and go very quick on the representation. Who am I? For those who were not in the morning yesterday, my name is Jose Aguinaga. I work, you can find me on Twitter handle JJ_Aguinaga. I work as a web engineer, having working with JavaScript for over 7-8 years. I work especially with the startups. I mostly specialize in the fintech industry. I have a very high interest in privacy, and that's a little bit of the reason why I wanted to do this presentation. I want to talk to more about the topics or the technical terms that we can use and the technical technologies we can use in order to enhance privacy on the front-end solutions or the front-end side of things. Quick disclaimer, and I just need to make sure this one. So I'm going to be talking a little bit about crypto-related technologies, which means that sometimes I will use some terms that I might not be dive too deep on them. Sometimes I will use those terms wrongly. Please help me accountable on those terms later on. But I'll just try to make things that try to explain that as much as possible. But please just make sure understand that a lot of that stuff is related on the crypto side of things that might not be able to dig very deeply. So what are zero knowledge solutions? And I guess for first going depth or going zero knowledge, I need to describe what are trust-based solutions. And trust-based solutions are, we'll say, that are the most common solutions we have nowadays, not only on technology, not only on web development, but most of the things that we use nowadays are based on a trust system. I trust somebody with something in my life. A very good example that I like is when I go to a hotel, I trust the hotel when I leave my things there, they're not gonna steal it, that they protect everything properly with a lock, that nobody can just go and open and just grab all most things, right? But I'm trusting the hotel that their security system works in that way and they are protecting the things that I have in there. From a technical perspective, that's very equivalent to when you are using a service. If you are a service provider, you tell the client, hey, the data you're sending me, I'm going to protect it in a way that I'm only going to use it in the way you are intended me to use it, and I'm going to use the best technology available to protect it, right? So let's talk about, let's say, Dropbox. If you upload data, if you upload images, if you upload files to Dropbox, Dropbox knows what files you're uploading. If you're uploading a picture, it will show you the image because it knows that it's a picture versus, let's say, a PDF file or any other file, right? But you're giving that option to Dropbox to know it, and you're trusting Dropbox to take care of your data. The problem with those solutions, of course, is in case Dropbox, in this case, doesn't take care of your data properly or misuses the data that you're having, there's a very easy chance that other people can have the data. Dropbox got hacked recently, I think 2-3 years ago, and that leaked a few information from the users handling. If we go back to the hotel example, let's say that even if they are using the best lock system in your doors, if somebody sneaks in the reception and grabs everyone's doors, they can open it. It doesn't matter if the locks are very good, if the keys that are being used are not being taken care of properly, right? Now, zero knowledge solutions, and I put a little tagline there, is that I have nothing, right? And instead of you trusting the information, you definitely have nothing. And one way of kind of approaching this is being, you know what? I don't want to be in any hotel. I'm just going to stay in my cabin. I'm going to have my own homemade solutions. I'm never going to send data to anybody. And I'm going to install my own system and my own server. I'm pretty sure some people here have loaded their own FTP in their own servers, in their own basements. And that's kind of okay. I mean, in this case, you're not sending anything to any service provider. But the problem with that is, of course, there's not much you can do from a server's perspective. You can only do with the resources you have with the solutions you develop. And if you are a customer, you cannot really leverage on anything that you are being offered to other party. And if you're a service provider, well, you cannot get any data because data is not being transferred. So when I mean zero knowledge proof solution, so to speak, is even though I may have not nothing on you, or in this case, you are given information, you don't know what information it is, but the other person still know you are using something. This gets a little bit complicated, but I like a very good example is, let's go back to the hotel analogy. Instead of the hotel giving you a key that they use in their internal system, let's imagine that instead of that, your room is locked by your own padlock. So instead of you having to trust the hotel security, whatever security they use, instead you bring your own security, your big ass padlock that you just put it. Some systems, like locker systems, work like that. You know, if you see this in this picture, you know that something is there, but you have no knowledge other what is in there, right? So that is more or less the approach that I want to take when I want to talk about these zero knowledge solutions. I mean that you're able to, with JavaScript, implement solutions that allowed using service providers that they don't learn anything about the data, okay? The most common term, when I move about, I'm oversimplifying a lot of the things from a cryptographic perspective because you need to prove that the other person has access to the other thing. So in this case, the hotel analogy goes a little bit weak because you have to tell the hotel, hey, I have access to that key. So that way, even if you put your padlock, the hotel trusts you that you know how to handle that information. The most known proof for whether a person from a cryptographic perspective can prove that something has access is what they call the circle room, where you go to a room, it's a circle, so you can go back and forward, there's one entrance, but at one end on the circle there's a door in the middle blocking it, and you need a key to cross it, right? So you need to prove to the other person that you have access to the door, but you don't want to reveal neither the key, neither how you unlock the door, anything. So the way to prove it without giving away any of that information is just enter the room, go against the door, and come out from the other way. So that way you know the other person, which doesn't have the key, gets blocked by the door, goes back, and you see that the other person can go around. So this is kind of like the proof of these systems that allow you to tell you, okay, I have a knowledge that other people go around. Again, this is oversimplification, but I just want to go and dig a little bit on what does that mean. And then from a technical perspective, I guess sometimes this gets confused very easily with end-to-end encryption, which means that going back to the hotel analogy, as you can tell, I really like it. Not only you bring your own padlock, but you also, the hotel has its own padlock, right? So even if Dropbox has a data breakage, or they stole their keys, you still learn nothing from the system. But that's a subset, that's a superset, so to speak, of the zero knowledge encryption, right? We use that every day, so to speak, in a lot of systems. Like if you're logging in any online system, email, like Gmail, Dropbox, we do a little bit of that in order to compare, even though most of those services don't have your passwords, pray they're not storing them in plain text. They will use a hash to compare that at least they know the passwords. They're still learning something about you, right? Now, all this is very nice, but where does the web fit in all this? Now, server-side cryptography has been around. That's what we use most days nowadays, right? Like all these, like SSL certificates, we use most of stuff for encrypt and decrypt. We use our hash method authentication codes for certification authenticity of the information we're sending. That's super common in the server, and that's, as of today, is the base that we have in order to ensure that when we're giving data back and forward, we are safe, right? That's the basic of our own knowledge. However, on 26 January of 2017, without not much fuss, actually the W3C accepted as Web Cryptography API as a recommendation. So the support for this API is actually surprisingly big. And what that means is you are giving a browser the possibility to perform a bunch of cryptographic functions that allow you to use to perform any cryptographic capabilities such as encryption, decryption, signing, verifying things from your own browser. Now, if you're not amazed about this, I don't blame you, but to me it's incredible because over 20 years ago, or I think 30 years ago, encryption was actually illegal in many countries. Like, there's still, this is a very increasing topic, and I want, Jesus Christ, one topic. Hello? The NSA is way worse than I thought. Yeah. They don't like when I talk about cryptography in general. See? Alright, let's see. So, I guess the mic is off, or on, or off, or on. Yay! Awesome. Big round of applause for the guys over there. Yay. Awesome. So, as I say, it's a very big topic because, as you probably are aware, man, this is rough. I'm thinking about, there you go. All right. So as you're probably aware, in all over the world, the U.S. I'm just gonna do it outside. All right, I'm just gonna try to speak very loud, which is not that hard for me, but it's better. Maybe like this.
One, two. 1, 2. Not working.
1, 2. 1, 2.
1, 2. 1 second.
It's all red. See, I cannot make the NSA joke twice. So. Hello, yeah. Hello, 1, 2, 3, SHA-1, SHA-156, SHA-112. I'm just testing. I'm a little bit busy right now. Posso parlare un po'? Va. 1, 1, 2, 3, 4, 5. Credo che tu può bene, ma non lo so. I think my Italian is not good enough to get there. Sure. So there is a Mexican going to the United States now. That was just mean. Yeah. How a better one? Why Mexico never wins Olympics? I can make these jokes because I'm Mexican, okay? Because anybody can jump, swim, and run already cross the border. There's another Mexican giving a conference over there, and he's like, what happened? I'm not so sure. Okay, I guess. Yeah. I mean, I can talk with a microphone. I mean, are we good? Okay. So we're doing it. We're doing it live. Okay. Okay. Perfect. All good. No worries. I'm used to the best ones. Awesome. So as I was saying before the NSA. Oh, on. It's all good. See, maybe it's just me moving all this around. So I'm just gonna put this here. Just hope for the best. All right, back to cryptography. So as I was saying, cryptography to me has been a very important topic because nowadays I think it's more important than ever. As I said many years ago, it was not only a crime, but a lot of things lately. A lot of it has been showcased that many practices that we use in cryptography, especially in public-private key cryptography, public key-based cryptography, has been weakened by the NSA, has been involved intervened by the U.S. government, and there's many three-letter agencies that are involved or interested in to make sure that maybe things are not as strong as we will want it to do. However, the open source community is still pushing a lot of the standards that we use nowadays to do cryptography. And to me, it's amazing that a browser, something you can download it anywhere, has strong capabilities as some of the most strong client-side tools that we use, like OpenSSL. I want to show you, I mean, just for instance, an example. This is real JavaScript code that we can use today in most evergreen browsers to do using a function that's called PBKDF2, password-based key derivation function, which grabs a string in order to generate an actual private key that you can use to encrypt, to decrypt, verify, and sign anything using proper math that allows us to not only protect things on the server side, but also on the client side. I use this for a very curious experiment that I want to show. I'm not going to go and spend too much time, of course. So using the Web API, I built this web page that it's called Deniable website. And what I'm trying to show in this website, open source is on code is on GitHub, is I'm trying to use this concept of what it's called deniable encryption. And what I mean is that you don't know what is the content of that website, that everything is encrypted in that website. And just to tell you that is the case, this is the open source, this is the code. So if you can figure out what is going to happen there, you're a wizard, and yeah. But most people not. So what I'm doing is actually, this content was encrypted before, and I embedded it in the presentation, I embedded it on the website. And when I click on that little button, the content was decrypted. Now, in order to decrypt that content, I'm just going to show for the sake of this example, I'm going to turn off the internet. I'm not connected to anything. The content, the website is decrypting itself slowly. The password and the content of the website, it's by itself being decrypted slowly. So for instance, I'm doing the example, inspect the network or turn off your internet and look for the word Fidelis. So we have here, and we look for Fidelis. We cannot find anything. I'm not lying. However, if I click here, you can find the word there. And this is where you go, oh. I'm just joking. But the whole thing is that that content was only shown to you when I decrypted, and I only gave you the tools to decrypt that within the same web page. There's no way you can know what is the content in there in that website until you decrypt it, of course. And I'm only using Web Cryptography API. This is a very interesting experiment, not only from a web perspective, but a lot of people say that we might need to rely on this kind of techniques when, let's say, you might be crossing the borders, the US border with your cell phone, when there's people telling you like, oh, you need to have access to your PIN. And you, at some point, we might be able to prove like, oh, we not only don't have access to the PIN, but we can prove that we actually don't have access. And just before I finish on that example, just to give you an example, this is an image. I didn't fetch it from anywhere. It was embedded in the website. And again, I only put it inside of the website. As you can go to the website, you can see all the example. I am describing a little bit further on the concept of deniable encryption. Technically, it's not deniable encryption because, as you can see the source code, you can see that something has been encrypted. It's a form of steganography, which is just hiding contents through cryptography. And yeah, I'm just trying to explain here a little bit of the crypto grounding behind it. Let's go back to the presentation. Yay. Awesome. So And this is again, it's just I know you don't know where I go, and if we go to the same to the hotel example, this apply just kind of showcase that you don't have to know you don't know what is behind the door, and you have no way to know it. This is a very simple analogy that I can be embedding content as much as I can. I actually embedded within the application just a private key of a Bitcoin wallet if you feel lucky, and you can get like half a Bitcoin. It's not that much, but maybe you can decrypt it. But the whole point is you cannot know how further that content is, and that is just everything with web cryptography. Um, to kind of land down more, this is a cute example, but what are more actual real world examples we can leverage web cryptography into? And when Evernote published their updated privacy policy in February of this year, they said like, hey, by the way, you cool if we start snooping your notes for improving our machine learning algorithms. A lot of people were like, no, actually, I'm not cool. And for a long time, this project called Laverna, it's an open source. It's a little bit dead now, but it's still working. It's kind of an Evernote alternative, and they use client-side encryption to make sure that if you can use kind of like a dumb backend, such as Dropbox, to send the data encrypted. So Dropbox learns nothing. You can be sending a chunk of encrypted data, and that way you can still have this notebook functionality without necessarily having to leverage on Evernote, right? Another good example, one of my favorite ones, is Boxcryptor. It's a German-based company. Again, they leverage on Dropbox. Not because I dislike Dropbox or anything. It's a really good tool for storage, but I just don't want them to know what I'm storing. And what they do is they use client-side encryption, again, to generate a key that encrypts every kind of file that you're sending to Dropbox. So you can still use it as a dumb storage, but in that case, everything is protected not only by whatever Dropbox schema they're using, but by your own security. All right, we're getting very close to the end, so I just want to close with just how we can take it from here. I think from whenever I'm learning a new topic, or whenever I want to showcase a new topic, I think a presentation should kind of give a starting point for other people to be like, oh, that's cool, where can I go from there? The first one for me, I think when I started poking on crypto, privacy, security, all that stuff, I realized that even though I did my background in computer science, I was very weak in a lot of security topics that I still, in many ways, I am. So very strong recommendation if you want to refresh or get started with crypto, like the proper math foundations and the proper understanding of crypto. I recommend this Coursera course. It's free, and it's an introduction by Dan Bonnet, the professor at Stanford University. There is a GitHub example. It showcases most of the supported APIs over there that you can use on the web, using the Web Crypto API. The repository is up to date, but you also can check. You can just do Mozilla Developer Network and Google the Web Crypto API. They have also very good examples over there. Another one of my favorite companies for kind of like not only working from a web perspective with API, but also playing around with it and actually use it on a daily basis is keybase.io. And what they're trying to do, I'm not affiliated with them in any way, but what they're trying to do is they're trying to make end-to-end communication for the masses. So they allow you to generate a proper private key online based on your own desktop, and they use what it's called an indirect verification system. So they use your Twitter account, they use your social persona to validate you are who you say you are. If you ever work with PGP or GPG, any of the web of trust schemes to actually do communication or private communication between two parties, you will find this extremely refreshing, because sometimes it's not very friendly or not very easy to try to do secure communication with a person that is not very technical. I have been very successful. I've been working with some articles with some journalists in New York, and it was actually surprisingly easy to just use Keybase for communicating safely. I have a Keybase profile, and I'm only showcasing it to you because I just want to show the example of how this Keybase replaces the web of trust, so to speak. They use my online profiles to validate that my public key, which is that's the fingerprint of my public key, is the one that I say I have personally. So it's also you can go there, check it out. But even more, what I think is even cooler than that is they also implemented, to me, most the most successful online library proper implementation of PGP. There's a few ones supported by Google and a few ones supported by other companies, but the one that Keybase did, it really allows you to exchange not only and generate RSA keys, for instance, in a real time without necessarily killing your machine, because it's a heavy computing application, but also do it on your browser and allowing people to leverage on this library to perform, as I say, these client-side solutions. So if you can, when I'm building a project for, especially that I want to leverage on a little bit of web cryptography, sometimes I use pgp.js or just the native web crypto API. I also spent some time and built just a few npm packages that are just a wrapper around keybases. And what it does, for instance, a good starting point is the keybase generator, which is just generates a private key for starting to do public key-based communications between different parties. And from there, you can perform some tasks within the web browser, such as encrypting, signing, verifying, and of course, decrypting as well. I'm getting very close to the end, so the only thing that I want to say as a conclusion is the Web Cryptography API is a very healthy, supported API that most modern browsers can use. I'm going to go back real quick to the... Woo, no, that's one of the healthiest and most supported APIs. You can perform and leverage solutions that are work a lot and that work very well on the client side without having to put yourself liable. Because at the end, what is the advantage of zero knowledge solutions? You as a company or as a service provider, your agency, your the place you work, you remove yourself from the liability you might have from using these kind of solutions, because the encryption is doing the server side, I mean client side, and that allows more freedom to the user and less liability to yourself. All that being said, I just want to say thank you very much.